Students, I welcome you all to the course on Statistical Methodology for Psychological Research Part 2. In this lesson, we are going to learn the importance of studying the hypothesis testing about the difference means for two dependent correlated means and overview. Learning objective. Let us begin with to understand the mean difference between two groups and its conditions, to study the comparison of means between two groups that are imposed on the dependent method, to examine the underlying population from which the data samples are obtained, to evaluate the calculation and interpretation of difference between two variables. Here we are going to start with the description of the independent and dependent correlated means, difference and their parent population. Dependent sample. The parent population for the independent and dependent means can be a heterogeneous or homogeneous. In reality, there may be heterogeneous group and homogeneous group. Here, when heterogeneous population refers to population with different variances, whereas the homogeneous population have a similar variance. It is important to consider the homogeneity or heterogeneity are present in the data that is based on the population when selecting an appropriate statistical test. Independent sample. For independent samples, if the population variance are equal, you can use the standard method of t-test. If the population variance are unequal or unknown, you can use a Becker's t-test, which is robust against unequal variance. In both the t-tests, assumed that the populations are normally distributed. Independent means. The difference between independent means refers to comparing the means of two separate and unrelated groups or populations. In this case, the sample or groups are assumed to be drawn independently from their respective populations. For example, you might compare the average height of men and women, where the heights of men and women are independent of each other. Given two independent random samples of size n1 and n2 with the corresponding mean x1 bar and x2 bar, and combined standard deviation is capital S, we may be interested in testing the hypothesis that the sample means come from the same normal population or not. The test statistic is as follows. The formula for calculating the t is equal to x1 bar minus x2 bar divided by s into square root of n1 into n2 divided by n1 plus n2, and the standard deviation capital S is equal to square root of summation over x1 minus x1 bar the whole square plus summation x2 minus x2 bar the whole square whole divided by n1 plus n2 minus 2, where x1 bar is the mean of the first sample, x2 bar is the mean of the second sample, n1 the number of observation in the first sample, n2 the number of observation in the second sample, S is the combined standard deviation. Here the actual mean is a fraction. The deviation should be taken from the assumed mean. In such a case, the combined standard deviation is obtained by applying the formula S equal to square root of summation over x1 minus a1 the whole square plus summation x2 minus a2 the whole square minus n1 into x1 bar minus a1 the whole square minus n2 into x2 bar minus a2 the whole square whole divided by n1 plus n2 minus 2, where a1 is called as assumed mean of the first sample, a2 is called as assumed mean of the second sample, x1 bar is called as actual mean of the first sample, x2 bar is called as actual mean of the second sample, n1 and n2 are the number of observations in the first and second samples respectively. Example. Two types of drugs were tested on 5 and 7 patients for reducing their weight. Drug A was imported and drug B indigenous. The decrease in weight after intake of 6 months are given below. Drug A, drug B, data are given here. We are going to check whether is there any significant difference in the efficacy of the two drugs or not. Which drug would you prefer for the situation? Let us take the null hypothesis that there is no significant difference in the efficacy of the two drugs. The alternative hypothesis states that there is a significant difference in the efficacy of the two drugs. The level of significance is fixed at 5% or we call it as 0.05. Solution. For this, we are calculating x1 and we summing up, that is equal to summation x1 equal to 60. We can able to see here. Similarly, x1 minus x1 bar is obtained, and the whole x1 minus x1 bar, the whole square, the values are given as sum, that is equal to 10. Similarly, we are doing for x2, the summation value is 77 is given here. Similarly, we are doing x2 minus x2 bar, the whole square, the summated value is 44. Here the formulas are given for the test statistics t, and for standard deviation are given with the corresponding values of S is 2.324 and the modulus of t values 0.735. Here the calculated value of modulus t is equal to 0.735 is less than the table value, the null hypothesis accepted. Hence, there is no significant difference in the efficacy of two drugs. Since drug B is indigenous and there is no difference in the efficacy of imported and indigenous drugs, we should buy indigenous drugs, that is B is preferable. If the data is not normally distributed or the population variants are unequal, in such cases you might consider a non-parametric test like the Wilcoxon sign rank test or the permutation test. Let us summarize what we have learned in this video. In this video, we come across dependent sample, independent sample, heterogeneous group, homogeneous group with illustration example. Students, we continue in the next video. Thank you.